We are doing this test today in Wendell's bee apiaries. It's great to have him helping us to do this work here. The whole purpose, we are trying to do demonstration for the beekeepers so they can look at the video and utilize it in their own operation. In Saskatchewan, as most of the beekeepers know, most of the beekeepers raise their own queens and they try to breed queens more hardy for the winter, high honey production, and recently they've been trying also to select for bees resistant to varroa mites. There's 2 tests right now for varroa mite resistance, actually 3. The first one, it's the oldest one, it is freeze kill the brood. In this case, we can cut a piece of comb with some pupa, put in the freezer for overnight, come back next day, put the plug back in the hive and wait for another 24 hours and find out how many of those pupa been removed by the bees. We advance a little bit by using liquid nitrogen. We can freeze the pupa right in the hive in the same day, and after we freeze them, that will kill the pupa. Come back 24 hours later and count how many pupa have been removed by the bees. And we get the percentage. If it is above 50 or 70%, this kind of colony, we can include it in our breeding program. The last test, it was developed over the last 3 years, and that one, they extracted certain chemicals from pupa infected with varroa mites or deformed wing virus. This kind of chemicals been taken out, and now we can apply isolated number of cells, and within 2 hours the bees will trigger that behavior, and the bees will start uncapping them and removing the pupa. So that test, because it's more efficient, it takes only 2 hours to get the results. We are trying to utilize it in our system. Hopefully that will cut the cost of production and encourage more beekeepers to utilize it in their own operation and adopt the technology.
So now we're just going to go into the hive and we're going to look for a frame of solid brood, and we're just going to check for the queen before we shake the bees off. And then we're going to shake the bees. We're going to uncut the cells, and what we're looking for is pupa with purple eyes or red eyes. And when you're looking for those, you're going to want to start at the center of the brood pattern, not the outer edges, because that's generally when they'll have the purple eyes, because they mature inwards to outwards.
So those ones, you buy them from any food supply place, cream holders. And actually we ask one of our team members to take the bottom off. We file them so they are sharp. We try to use stainless steel. It's easy to clean and also sterilizing them. So we don't have to worry about taking any infection or disease from one hive to another hive or from one operation to another operation. Each one, it isolates about 45 cells in this frame, and that's the ones we are going to apply liquid nitrogen to kill the pupa underneath. And once the bees realize there is killed pupa underneath the cap, they start taking it out within the next 24 hours. Some hives can take about 90% at one time, some hives 10% or 20%. That's variation based on the genetic stock and the source itself. The ones with a high percentage of the hygienic or removal of this pupa, these are the ones we include in our breeding program. That area we marked early on in this frame, which has the pupa at the right age, and that's the purple eye pupa. We now put the isolate and try to turn it around just to make sure we are not really damaging all the cells. Underneath, definitely some will be damaged. It's not big deal. However, gently we can keep just screwing it around until we hit the middle part of the frame. Based on our experience and the research we have done, we like to have 4 replicates for the same hive. If we look at the rings here, we are going to mark them. That's number 1, number 2, number 3, and number 4. In the United States, they like to have one big ring about 3 inches wide, and they take only 1 reading for each hive. However, in our system, we use actually 4 rings. Each one, it has about 45 cells. We count them, and that will give us an average of 4 replicates, and that will provide us with better, robust number to represent the hygienic ability of the bees of that hive. So at this time, we're going to take the liquid nitrogen using a dipper, and this volume, it's about 15 milliliter. And we dump it right inside the isolation ring. Actually, at this time, once we scoop the first one, we wait until all of this liquid nitrogen, it evaporates. That helps to kill the pupa faster. If we keep adding them all the time quickly, actually the pupa will freeze and stay alive. So now we are going to apply it for the second isolate, and that gives enough time for the first one to thaw out. So now we're going to apply again 15 mils of liquid nitrogen. You might think this is taking a little bit longer time, but this is the proper way to do it. Some people try to speed up the whole system and just to keep pouring number 1, 2, 3, 4. That does not give enough time for the pupa to get killed. Spacing it out, it gives time for the pupa to thaw out. That way it breaks the whole cells and the whole system inside the pupa will break down and die. So now we're going to start the third round of applying the liquid nitrogen, and that will be the last one. And the whole cost of the whole system is quite simple. One like this, it has 30 liters. It can be enough for the whole year or several operations at the same time. So it doesn't really cost you that much to run the test. It's worthwhile to do this kind of stuff to add that trait to your bees, and that will help you to keep healthy bees, lower the number of treatment using chemicals. At the end of the day, you have survived colony through the winter. Smoothly, we can take it out. So that's number 1. Try to take this one here. Actually, it's really hard and resisting. So that's number 2. See, this one I cannot take it out because it's still cold. This one I cannot take it out. So I have to wait for another minute or 2. If I force it, it's going to damage the caps of the brood, and that's no good for the test. And now the cell phone is handy because we can take the records and print it out and count the cells, how many is still capped and how many removed. This frame right now, it's ready to insert it back in the hive, and at the time as we insert it, we know exactly which frame was that. We wrote it on the side here, AW95. It's preferable to put it in the same position where you took it out of the box. So that way, still the cluster and the bees are oriented the same way. That's the one we applied the liquid nitrogen to part of it. So as you notice here, Marika pulled out the frame. These are the 4 circles we did yesterday. The bees start already removing the caps, and you notice here almost 60% of the cells uncapped. So that colony, if we leave it actually for 24 hours, you will notice all of these capped cells will be removed out. So that tells me this colony actually it's good in recognizing the dead pupa and removing them right away. So by the end of the 24 hours, we expect all of the capped cells will be removed. Bees actually, if they are hygienic, they are able to recognize the dead cells right away and start taking it out. It tells me it has the ability to be resistant to American foul brood, European foul brood, or varroa mites, because all of this unhealthy brood trigger the bees to clean them out if they are hygienic. If I am a beekeeper, I will use this colony as a breeder to propagate the lines of the stock in my operation to have actually naturally resistant bees to use in my operation. I'm going to take the second picture. Again, cell phones becomes really handy. And you notice here in my second picture, I can count the cells and go back and do my calculation. In the old days, we used to draw all of the stuff and count them as soon as we go home. Today we're going to do the unhealthy brood test. There's a chemical which basically extracted from unhealthy brood, and that chemical, it can trigger the hygienic behavior in honeybees. We got the chemical from the lab. We had to prepare the proper concentration of the product in this little vial here, and we have here the applicators. After we prepare the chemical in the hexane, we'll try to fix it in the applicator by inserting it in, and we pump the product a few times like this until we get the product inside the applicator itself. And once you spray, you see now the boom of the chemical itself is spraying outside. So after we open the hive, which basically we are interested to test the hygienic ability of the bees in those ones, we look for a frame with capped brood, as you notice here in Marika's hand. In this test, actually, it's different from freeze kill, because as long as the cells are capped and the pupa at early stage of development, it's fine. You don't have to look for the pink eye pupa to run the test. There's a sharp edge in one side. So we try to squeeze and just to keep screwing this one so we don't damage the cells so much. Since there is a plastic foundation here, we reach the plastic foundation in the middle. So this is as much as we could bring it in. So it's ready now for our application. We get our applicator. We will wait for just a few seconds until all the hexane evaporates. And now we take this one out. So this one, it's ready to go inside the hive, and we'll leave it for 2 hours. At the same time, we have to take a picture. So we count how many cells we started with as capped ones, and the cell phone becomes handy in this case. So that will become the original base picture to compare to after we incubate it inside the hive for 2 hours. So again, this is a hive. We have to mark the hive with the same numbers. That's AW100. And to know the frame from the top, we do the same thing in the top here. And we have to place it back in the same position as we took it out from the hive. We leave the frame here for 2 hours. And after 2 hours, we come back and pull out the frame, then take a picture of the same area we treated, and we count the cells uncapped. Based on that, we can calculate the percentage of uncapped cells successfully by the bees. So that higher the percentage, that tells me the hive, it has more hygienic ability and it becomes more resistant to varroa mites, as well as also resistant to the impacts of the deformed wing virus. And keep in mind, the chemical we started with, we call it unhealthy brood. It was extracted from brood, was infected with deformed wing virus and infected with varroa. And as a result of the infection, they produce this kind of chemical to trigger the bees to clean them up. So we are trying to put everything together right now. And instead of doing the other tests using the free scale, this is a little bit different because this is more specific to unhealthy brood caused by varroa mites and deformed wing virus. The beauty of this test, once it is done, you can get the results in 2 hours. It's quite expensive, so you have to be careful and use it properly. You notice here that we start cleaning the outside of the killed cells from the ring itself. They haven't really done much about cleaning up the cells. Same situation here. They cleaned up the whole thing here, but we might be a little bit early. We can put it back again and come another hour later and see what's happening there. You see the bees in that circle for damaged pupa from the ring. And if this colony and the bees were hygienic, they should have started uncapping the caps here. But you notice the bees here still trying to clean the pupa, which was damaged. Yeah, you can see this one taking part out. She took it away. But it seems like the chemical itself, it did not trigger any response here. You don't only pick up one colony and say, I'm going to breed from this colony. So you have to start with a large number of colonies. You test them at the same time with the same procedure and take the top 20% of those ones. So that way you can propagate the traits which you like and eliminate the traits you didn't like. And that way you have good queens, leading good colonies, healthy and sustainable. You notice one thing here in Wendell Honey Farms. The colonies here are 6 frames. And that's kind of really quite unique for so many people in Saskatchewan. He's using this one as a source for his breeders for next year. So there's a queen down in the bottom, and he can winter those ones actually outdoors. They put 6 together and wrap them, and the colony will be 2 stories, and that's the one will be used for wintering in Saskatchewan. There's some colonies will stay like this, and these are the colonies are used to replace the dead outs next year. So that way they don't rely on any bee imports, and they can become self-sufficient in their operations.